Good evening and welcome to Astronomy Off Tap Edinburgh. This is a very special month. We are celebrating 3 years of Astronomy on Tap Edinburgh. 2 years of that was actually on tap in Edinburgh. We're now coming up on a year of being online. But the advantage of being online is we have our audience now coming to us from all around the world, which is wonderful. And we're also able to get speakers from around the world. So we have a bit of an international flavour this evening. Before we get into our astronomy content for the evening, we just want to do a little shout out. Some of you may already be aware that yesterday was International Women's Day. And we only ever have a few people who are on screen, but there are a lot of people behind the scenes who make Astronomy Off Tap happen. And I am going to show them to you now. So you will see up in the top left, that's me. I'm Rachael Livermore. I'm your host this week, but I do other things other months. Right up the top there, we have Becky, who is brand new to us. She's going to be helping us out with young people social media and other things, I'm sure. On the top right there, we have Erica, who you may see some of the videos on YouTube in between events, which are always hilarious. At the bottom is Amy, bottom right, that is Amy, who has hosted many times in person, as well as since we've been virtual. And at the bottom left there is Rosie, who is actually doing the tech for us this evening. So these are just some of the brilliant women, plus me, who make this event happen every month. And we are also very excited to be bringing some brilliant female scientists this evening who are going to talk about things surrounding life in the universe. And in particular, we're interested in looking for life on Mars this evening since the launch of the Perseverance rover. But we're going to kick things off, as always, with a little look at some of the space exploration that's going on currently with Fred's view of rocket launches taking place in March. So I will hand over now to Fred.
Hello, hi, can you hear me okay? And can you see my screen? Can you hear me? Right, can you hear me now? Okay, hi, right, I'm going to share my screen. So, March launches of the rockets. It's actually a quiet month, so there's not that much I'm going to talk about, but I've not included any military stuff or anything like that. Right, sorry, I had the loop back feed there from YouTube. Right, so the first one to go up is on the 7th of March, which is actually past the SpaceX Falcon 9, and that's launching 60 satellites for the Starlink broadband network. And this is designated mission number 20. And it's being launched using the rocket of serial number B1049.8. And then next up is a Soyuz redocking operation, where there's going to be a Russian and a NASA astronaut are going to be moving that Soyuz MS-17 from one part of the station to another part of the station, and it's going to take about 20 minutes, sort of. That's on the 19th of March. And then on the 20th of March, there's going to be a Russian satellite rideshare, and it's going to be launching a bunch of cool things like observation satellites, active debris removal demonstration mission for a Japanese company, and a bunch of microsatellites for Japan. And that's being launched on the Soyuz 2.1A. Thank you. No, there's one more. 25th of March, the OneWeb, 36 satellites going up for the Russians, and that's on the Soyuz 2.1B. Yep, that's me.
Right, lots of space exploration going on this month. We're now going to dive straight into our science for the evening. We're starting off with Prat Desai, who is just finishing up her PhD at the University of Edinburgh, developing and field testing a portable water activity detector, which has been optimized for planetary exploration, which all sounds very exciting. And we are, I'm sure, particularly interested in knowing whether we can detect water on Mars. So welcome, Prats. For viewers on YouTube, do remember that you can pose questions directly to our speakers. Just pop them in the YouTube chat, and then we will ask questions after the talks. All right, over to you, Prats.
Hi, everyone. I'm Prats. Thank you, Rachel, for the introduction and for inviting me as part of the program. Let's have a look at the presentation that I prepared earlier for you guys. Can you guys see the screen? Perfect. Okay. So let's start off with the exciting topic for today, which is looking for habitability on Mars. Right, so starting off, let's recap what happened in 2018. We basically found out through ESA's Mars Express mission that there was a possibility of presence of massive lakes, subsurface lakes on Mars under the South Pole. And in 2020, there was a confirmation that there were not just one lake, but there was about more than 7 subsurface lakes on Mars. And as part of a scientific community that, is involved in looking for life in, solar system and beyond, that's something which is really exciting for people like us, because as we know that all life that we know of is really, really supported essentially through liquid water medium. And, currently we've got Perseverance rover on Mars, which just landed last month, which has got myriad of instruments which deal with, looking for extinct life or different forms of life, actually, which is really exciting. To those of you who still do not know the objectives, I'll just have a quick recap. So the first objective of the mission is to find rocks that can support life in Mars's ancient past. You can have the second objective, which is, finding rocks which are capable of preserving life or traces of life. And the third one is to drill these core samples and, secure them safely. And the fourth one is, producing oxygen through Martian carbon dioxide, which is really fascinating for future human missions. I would like to draw your eyes to the first objective. So one of the ways that you can find rocks that could have supported microbial life in Mars's ancient past is to figure out if their chemistry is basically has any trace of presence of liquid water around it. Because again, as we say, that this is wholly focused on presence of liquid water, as it's an essential medium, which means that liquid water plays a very, very important role in habitability studies. Now, the subsurface radar, which is also located on Perseverance, has one of its major, one of the major objectives is to look for subsurface pockets of water on the surface of Mars. Now, there's a big drive for, looking for water on Mars and confirming it, which brings me to the question for you guys this evening, which is looking for water enough for habitability? Or should we be looking for something more definite? Well, my answer to you guys is that we should be looking for a factor which gives you a direct indication for life rather than just a possibility. And that factor is called water activity. To those of you who do not know much about it, it's actually not the same thing as the total moisture content or, water in a substance. It's actually the measure of chemically unbound water. As you can see here in the figure, you've got the boundary indicated by total water content, and you've got chemically bounded water molecules out here. And then you've got these free water molecules around here. Now, water activity is basically these free water molecules. So it's sort of a subset within the total moisture content. And it's basically this unbound water that supports the growth of microorganisms in a substrate, thereby acting as a direct indicator for life. Now, all life that we know of is found within the range, a very narrow range of 1, which is on the scale of water activity, indicates pure water, and 0 is no water at all. To give you an example, I can quote honey, which is basically located along the borderline of the scale. And then I can quote some fresh fruit, which is located quite quite on the higher end of the scale. So if you must have noticed that honey tends to not go off that quickly. It tends to remain on a shelf for a long time because microbes or organisms cannot grow that easily in honey as they can in fresh fruit, for example. And that is why your fresh fruit tends to get moldy a lot more faster than, your honey would go off. Now that we have established what water activity is, it is quite apparent that it is a very important factor for habitability studies, not just here on our planet Earth, where it is a major part of food industries. It is also a very important factor for habitability studies on Mars, which we are interested in today evening, icy moons like Enceladus, and other aqueous conditions in the solar system like Titan and other bodies. Now, surprisingly, there has been no mission that has involved water activity measurement to date, despite it being so important. And that is why we wanted to change that. So we decided to make a water activity detector for space exploration using space instrumentation constraints in mind. That is by using the design should be smaller, lighter, low power, faster, should have small sample sensitivity, and functional in extreme environments. This is the first prototype that we made. It was aptly called MUFFINS, which stands for Mars Underground Future Field Hydro Investigations and Other Non-Terrestrial Systems. It involves a sensor at the head with a cap, and the lower end is exposed to the samples, and together it forms a closed environment for water activity measurement. In real life, this is what it looks like. It's quite tiny, as you can see with the scale here. And this is basically comparison of our instrument to the current commercial systems that exist today in food industries. So this is the smallest system that we've made so far. And, it is almost at least 5 times faster than the commercial system, which is actually brilliant for us. Now that we had a system in mind and created it, we decided to take it in real life conditions to test it. So the first site that we chose was Bowlby Mine because it acts as an analog site for Mars in the UK. And because of its composition, it's got a lot of sodium chloride, which is also found abundantly on the surface of Mars. We carried out some interesting experiments which involved incorporating muffins on top of an exploration rover in the mine. I'm standing here with my colleague from Luleå University. We also carried out experiments by putting the sensors into the water body using the rover's arm, and many such experiments. Outside of this, we actually tested some brine pools or the naturally occurring brine samples. So since this mine is 1.1 kilometers deep, the deposits of the mine are around 250 million years old, which means it's very, very old. So it's essential for scientists, across the world to figure out if there were things that were preserved in these brines, how do they look like today? So you could track that, and similarly in Perseverance rover or further missions in Mars to figure out how extinct organics actually preserve through long durations of time. So it's actually a very, very nice place to do such experiments. Further along, we decided to improve our prototype. And as you can see, it's slightly swankier machine, which can hold 3 different samples at once. It's very easy to operate. You just open the lid, you pour the samples, and then you press the lid back on again, it will give you the reading. Now that we were happy with this, we decided to test it in a different field site, which was the Basque Lakes, which are very well known, again, as analog sites because of the high concentration of sulfate and magnesium salts. Again, sulfate and magnesium salts are abundant on the surface of Mars. This was carried out in collaboration with the SETG group of MIT. And as you can see, these are the salts, these are the brines that you can find in the ponds, which look really, really lovely. And from the ground, you can see these are the different concentration of magnesium and sulfate salts around, where we carried out different experiments, comparing my equipment to the currently existing equipment available and figuring out different challenges that were met and how to improve this further. Talking about future directions, you might ask, what's the next step? Is it directly to Mars? Well, from instrumentation development point of view, you've got something called as technology readiness level. So when you first have an idea, you start at level 0, and then you look into the feasibility of stuff and formulate the technology. So you eventually move upwards. And then you eventually get to TRL 4 when you actually demonstrate your prototype in a laboratory environment or a controlled environment, followed by performance in sort of environment that you want to test it, like analog sites. So right now you can see that we are, I've highlighted it here, that we are currently at TRL level 5, but we are hoping to move further through the TRL levels, hopefully in future, to ensure that the equipment is space ready, which is at TRL level 9. The prototype will be subjected to a lot more tests, like reliability tests, operational tests. It will be subjected to vibration tests for launching, stress tests, and many other real life, stresses that can be applied on it to ensure that it is space ready. So with drive and determination, I think we will be able to get this instrument out there in few years to come. It may not look the way it is looking right now, but it's the hope that, once we discover liquid water, the next step would be to confirm the habitability through water activity. So in conclusion, water activity measurements have not been previously carried out, and therefore we decided to optimize and create, one device in contrast to conventional commercial systems. We have also demonstrated that it works on a rover for future missions. And with so many potentially habitable regions being discovered, including the subsurface lakes on Mars, measuring water activity becomes extremely critical as the next step for habitability studies. With that, I would like to again thank Astronomy on Tap and to all of you for your kind attention. And I'll take any questions if you like. Thank you very much.
Thank you so much for that, Prats. That's really fascinating and interesting that these places that are quite damp are considered good analogues of Mars. I think the place that I've been that was the most Mars-like is the Atacama Desert. Would you test anywhere like that in desert environments where you'd have very little water?
Absolutely, yeah. Atacama is also one of the analog sites on Mars.
Mm.
So analogs do not necessarily have to be very much Mars-like. It's great if they are, but there are different reasons why we test in different analogs. So the reason I tested this instrument in different sites was for the composition of salts that was available on Mars. So the only way that we could find these salts on Earth was in damp areas, even in the highest concentration. So I do not see why we can't test it in other places.
Yeah, that's really exciting. So some questions from our audience. What key characteristics of rocks means that they are most suitable for life?
There are different compositions that you want to look for. So again, interaction with liquid water. If ancient Mars, as we know of, had more liquid water flowing through it, so you would have some sort of chemical properties which would be present only or formations which would be present through liquid water. The other chemical compositions that you would look for would be carbon-based products or organic products, organic chemicals as well. This is some of the examples I can think of.
So the next question is, I think, quite relevant to a second talk this evening as well, which is when you're collecting these brine samples, how do you know you're not contaminating them?
Oh, that would be something that Jen would be able to take up very well. One of the ways to probably do that would be to ensure that I think the planetary protection comes into place because, first of all, when you are sending things into space, including instruments with it, they have to be tested, and quantitatively tested to ensure that they are not carrying any contaminants along with it. And as Jen will be pointing out later on how these tests are carried out in detail, you want to at the same time ensure that when you are carrying out, sampling, you are also carrying out, enough of, protocols to not basically cause contamination within the samples itself. So there would be procedures and automation, methods to be able to deal with that.
Yeah, it's something to be careful of with any space mission. So last question, is there an expectation that only extremophile microorganisms can survive in substrate on Mars?
Well, so far, considering the life that we know of here on planet Earth, Mars is a very, very extreme place to live on. So I can definitely say that what can survive here most comfortably cannot really survive on Mars. And so the first thing that comes to my mind would be extremophiles, which are quite hardy when it comes to radiation, because there's a lot of UV radiation on Mars. There's not much water either, so they have to be, susceptible to work with the environmental conditions. There is very little pressure as well. So again, that goes to extreme pressure-based organisms that you would want to, low pressure-based organisms that you would want to look at. And most importantly, there's not much liquid water around as well. So you would want to find organisms that are extreme in the sense that, the conditions on Mars can basically sustain it.
Excellent. Well, thank you so much. And do stick around because we're going to subject you to our speaker torture session later on this evening.
Thank you.
And yes, thank you. That was really fascinating. And we all hope that we see one of your instruments on a Mars rover in future. That would be very cool.
Thank you very much. That would be amazing.
And now, before we move on to our second speaker this evening, we have a bit of a game. This is something that we have always done when we're in person, and we have tried as far as we can to continue online. And for this, I am going to hand over to Amy. I hope. Welcome, Amy.
Hello, it helps if I unmute myself. Classic. Yeah, so I'm Amy. If you've done some of our live events before, you might recognise me as one of our host stars. I've taken a bit of a back seat during the online events for various reasons, but I'm very happy to be back for this month to share in our birthday celebrations. As Rachael pointed out, unfortunately, 2 of the 3 years that we've been in existence, we've now celebrating birthdays in lockdown, which is unfortunate. Our first birthday was great. We had cake. Everybody was forced to wear a party hat. It was like very much, yes, you will have fun. And everybody did. So we're hoping that obviously this time next year, things will be back to normal and we can celebrate together in person again, which would be wonderful. Have actual beer and not virtual beers. So in honor of this, we're going to run a little giveaway competition, which we have never done before. So hopefully it will work out. If I share my screen, then hopefully can see what we want to do. So hopefully you can all see this. So basically what we've done is that we've designed a virtual beer for our Astronomy Off Tap events, and we would like you to name it. This is fresh out of the tank, beautiful Martian brew, but we need to call it by something in order to, do some proper space marketing for it, which is where you come in. So basically we would like you to come up with a great name for it, and our team will judge our favorite name, and the winner will be a rare recipient of one of these Astronomy on Tap t-shirts. We will contact you for your relevant size and everything, and then we will get that made up for you and sent out. Half of our team don't have these t-shirts yet, so you are in a very special position to get your own before some of our team do. And we will also do a random draw from everybody else who has submitted a beer name to win a goodie bag full of fun space goodies from the European Space Agency and the European Southern Observatory. So there's several ways you can take part. You can either email us your suggestion at our Gmail address there, eddie.aot@gmail.com, or I will post this on our social media on Facebook and on Twitter, and you can simply comment your suggestion underneath and we will collate all of the answers from that and then decide on our winner. So because it's our birthday month, we will give you roughly a month to do this. So our closing date for this competition will be on Monday, the 5th of April, and we will announce the winners at our April event, normally on the 2nd Tuesday of the month. All right, so that's enough from me for now. So happy birthday to AOT. Again, massive thank you to all of the team for pulling together what's been a very difficult year for everybody, personally, professionally, and for our Astronomy on Tap community. So just want to say thank you again to everybody who I work with, and thank you to our audience for sticking by us. And hopefully we'll see you for a pint in the not too distant future. Back to Rachael.
Yes, I hope we can have real drinks pretty soon. But in the meantime, while we're online, it does mean that we're able to bring a wider range of people in than we were able to before. And so with that in mind, we're now heading over to Switzerland for our second science talk in the evening. And I'd like to welcome Dr. Jennifer Wadsworth, who got her PhD at the University of Edinburgh. So there is the Edinburgh connection. Is now based in Switzerland studying microbes in space, and is going to talk to us a bit about how we avoid some of that contamination when we're looking for life out there in the universe. So welcome, Jennifer. Very nice to have you with us this evening. A reminder to our audience again, do put any of your questions in the YouTube chat and we will put them to our speaker at the end of the talk. Over to you, Jennifer.
Thanks so much, Rachel. Thanks for the invite. And yeah, I'm really chuffed to be able to speak to you guys from across the channel. I will just share my screen now. There we go. Okay, so hi everyone, I am Jen and I'm an astrobiologist. And for those of you who aren't quite familiar with the field of astrobiology, basically, we're not very interested in many things, just life in the universe. Yeah, so actually it is quite broad. Basically life, the origins of life, all the way through to what's the likelihood of life existing elsewhere in the universe. So I'll be talking to you about that this evening, more specifically, life on Mars. And that's a question that's been at the forefront of the field of astrobiology. And even before the field of astrobiology was even really created, people were asking what's the likelihood of there being life on Mars? And it's really one of the main questions that we're asking ourselves still today. And let me just see if I can. There we go, it's my next slide. Yes, that's underlined by the fact that we have a brand new rover, as Prat's nicely introduced us to beforehand. The Perseverance rover successfully landed on Mars at the end of February, which is very exciting. And for those of you, I'm sure most of you saw it as well, the amazing, relatively high HD images and videos that it sent back, it was absolutely amazing. So as Prat pointed out, one of the main missions of Perseverance is to look for signs of life or past life on Mars. And Perseverance has instruments on it already, so it's equipped to have a look in situ at the Martian regolith and to see if it can find any signs of past life. But it also has a secondary mission, namely to store samples for a future mission to then bring back to Earth so we can actually analyze these samples on Earth. In the first Mars sample return mission will be very exciting. So that will hopefully, the next stage will take place in the next few years, and hopefully we'll be able to then analyze some relatively fresh samples of the Martian regolith here on Earth. Now, obviously, we were very excited to see what we find in those samples. But one thing that we as scientists really kind of don't want to find are microbes from Earth. And that's a real problem. And Prat's already kind of dropped the planetary protection in her other talk. It's something that's really kind of neglected when we talk about space exploration, but it's very, very important. And so I'll very quickly explain to you what planetary protection is. Basically, planetary protection is concerned with minimizing the risks of accidental contamination of organisms when conducting interplanetary exploration. And there are two kinds of contamination that we're worried about. On the one hand, we have forward contamination. So that's when we're bringing Earth life to Mars accidentally, or another planet that we're going to. And equally, we have back contamination that we're worried about. We're less worried about that at the moment, but it's also something that we really have to take into consideration. And so as you can see, the Mars sample return mission encompasses kind of both contamination fears, both forward and back contamination. So the space agencies that are involved are really kind of working on trying to minimize that risk as best as possible. So I'm talking about contamination, but you're probably thinking, well, what's the likelihood of this contamination actually happening? Because again, as Prat's pointed out, most life on Earth would really not want to be anywhere else but in its natural habitat on Earth. And this is where my PhD and postdoc work come in. As you can see in this picture, this is space. This is low Earth orbit, International Space Station. And in the circle, you can see a experiment platform, and that's the ESA Expose platform that's on the outside of the International Space Station. And you can send up various samples, biological and chemical samples, to be exposed to the low Earth orbit environment, which is particularly nasty. Lots of radiation, barely any atmosphere. It's not a nice place for anything that's grown up and evolved to be on Earth to be in. And I was involved in analyzing some biological samples that were sent up there for 1.5 years. They were exposed to the really quite nasty environment of low Earth orbits. And they were brought back down to Earth, and I had the pleasure of analyzing them during my PhD. And in this picture, we can see, this is a picture from a microscope, and the biological samples are stained, so we can see which ones are alive and which ones are dead. Green means they're alive and red means they're dead. And as we can see here, there are quite a few that survived. But more scarily, or interestingly, there was a secondary organism that is a lot more fragile that we would expect it to not survive the space environment, but actually another organism was able to protect it from the horrible environment. So it was able to survive 1.5 years on the outside of the space station, which on the one hand is really cool, but when you think of it in planetary protection terms, it's quite terrifying. So there you go, and you can read about that in our paper that was published a few years ago. So when you think about clean rooms, the kind of the rovers and the equipment that's like the water activity detection instruments, when they're integrated into the rovers, they're done in clean rooms. And as Prat's pointed out, all measures are taken to try and ensure that these rooms are clean, as the name kind of gives away. However, these places are not perfectly clean, and you do have sneaky microbes popping up and actually becoming resistant to the various cleaning techniques that are used. And that is a real problem that the space agencies are really still trying to tackle. And that's something that I looked at during my postdoc at NASA. So you have microbes that somehow get into these clean rooms. You have various cleaning techniques using physical and chemical sterilization processes. So using radiation, heat, pressure, but also chemical sterilization or cleaning techniques. However, some bacteria survive and then they become resistant. And then this creates a kind of an endless arms race of having to find new ways of cleaning things. And then you get resistance in the bacteria. And it's kind of a never ending thing, which is very problematic. And as I said, still an ongoing problem. So if you're thinking about bacteria and contamination and resistance to, ways to get rid of the bacteria, you're probably thinking, well, wait, this sounds quite, reminiscent of some of the problems that we're having on Earth. And you'd be right. Other places that we want to be very clean are, for instance, hospitals and operating theatres, where we want to control what kind of bacteria get in there. And this is just one example of how we can use technology that's actually developed for space exploration to tackle and hopefully solve some of the problems here on Earth. So often you might hear people saying, well, why should we invest in space exploration when we have plenty of problems here on Earth to solve to begin with? And the two aren't mutually exclusive. In fact, in the past, we've had many technological advances that have actually been made for space exploration, but actually they've been used also to solve problems here on Earth. So that's just one example of that. So back to planetary protection and contamination. Maybe we shouldn't panic. However, we need to be very careful when thinking about exploring other planets, especially places like Mars, where you could have certain environments that are potentially habitable for extremophilic bacteria or other life forms from Earth. Because if you know something about Earth life, that if it finds somewhere that it likes, it will colonize that place, and that can be a bit problematic. So there we go. Thanks so much for inviting me, and I'll be happy to take questions.
Thank you so much, Jen. That's fascinating and also a little bit terrifying.
As are the best things.
So a few questions for you. What kind of bacteria are you afraid might turn up despite all the precautions that we would take?
So the bacteria in the clean rooms, the various space agencies keep tabs on the bacteria that they find in the clean rooms. And the ones that are particularly not terrifying, but thought-provoking are the ones that can form spores. So bacillus, for instance, is a bacteria that can form a spore, and it becomes very, very resistant to the lack of moisture and also radiation. So it's kind of in a stasis state. It's not technically, metabolizing or anything. So if it gets in a kind of nook or cranny in one of the instruments, it could happily just hang out there until it finds, more favorable environments, and then it can, kind of spring back to life, so to speak. And so if you're on Mars and you have maybe some liquid water, because there are very salty, but there are patches of liquid water in parts of Mars, and it gets introduced and it likes it, then that's a real problem.
Yeah, and there would really be no way of eradicating it then, would there, as we know?
This is it. Once it's introduced, it's going to be very difficult to kind of get rid of it. Yeah.
So are you fairly confident that in terms of searching for life, that if we found life that was Martian in origin, we'll be able to differentiate it from anything that we had introduced?
This is a real problem. It depends how similar it is. So, we could probably, hopefully bring back the samples and sequence them if it's some kind of similar DNA-like structure. And if it's very, very similar, and then you read the sequence and it turns out to be a bacillus, for instance, then we could say, well, it's unlikely that it was actually originally on Mars. However, that's very problematic because you'll never know for sure, and that's why we need to be really careful about making the claims that we found life, or signs of life on Mars, and then kind of retracting them and saying, oh, well, I think we brought that life form with us. So it's very problematic. And yeah, and it's kind of surprising this kind of thing doesn't get mentioned more when you're talking about kind of, space exploration, because if people then lose confidence in our ability to kind of, make these statements with, quite a lot of confidence, then, funding for these kinds of programs will also disappear.
Yeah, and that would be a real shame. So some more questions from YouTube, lots of questions. So Perseverance is looking for signs of past life. Could you give some good guesses where would be best to look for current life, either on Mars or on other planetary bodies?
So with regard to Mars, I would say underground. My background is in radiation biology, so I was looking at how radiation can efficiently kill bacteria. And as Mars, as Prat's mentioned, has a lot of UV, especially on its surface, and also ionizing radiation to a certain extent, you'd probably want to go underground. Maybe in some lava tubes. There might also be some liquid water there, who knows? So far, the rovers that have been sent there have little drills. Some of them have drills, but they're not drilling down very deeply. I think maximum 30 centimeters or something like that. So you'd really have to go quite a few meters down to be more protected from the radiation and also the temperature variations. So that would be my kind of bet.
So you're pushing for a drilling expedition to Mars.
A deep drilling expedition. Yeah.
Deep drilling expedition. So do we need to protect ourselves from Martian microbes if we're bringing samples back to Earth?
Absolutely. I mean, we're not really expecting to find any live, microbes or primitive life forms on Mars, but we still need to act as if they might be there, just in case, because I'm sure we're all familiar with the horror films of accidental contamination from outer space and how easily it can kind of go out of control. Also, we're in a pandemic at the moment. That's just something that's, from Earth. It's not from outer space. And that can be very problematic with the way it's, it is easily transmitted. So the space agencies that are involved in the Mars sample return are currently working on very, very strict protocols to be put in place to make sure as best as possible that nothing can really escape, and that when the samples get sent around to the various research groups to be investigated, that there are very strict protocols in place to really prevent something terrible from happening. So even though we're not expecting live organisms to be in these samples, we need to treat them as if they do have live organisms in them.
Of course, as anyone who's read War of the Worlds will know, that if we do bring any Martians back, they're just going to die of the common cold. So it's all good.
Hopefully, or corona.
Or
yeah,
coronavirus.
Exactly.
So does planetary protection only apply to planets? How do tardigrades on the moon fit in with this?
So it's not just planets, it's any planetary body, I suppose. The moon is, so in planetary protection, you have various classes of destinations depending on the risk of contamination. So if somewhere is deemed to be potentially habitable, for instance, Mars, habitable for Earth organisms, then it's a higher class, it's a higher risk. So you have to take more precautions. Whereas the moon, we're not so worried. It's never had an atmosphere. It has water in the form of ice, but we really don't think that it was ever able to host life of its own. So we're not as cautious as we are, say, for instance, with Mars. However, smashing tardigrades into the moon is not such a great idea, because poor tardigrades. That's not.
Yeah,
that's
what
not
do
very
they
nice.
do to deserve that?
Exactly, but we're not that worried about contamination for planetary bodies, not just planets, but also moons, asteroids, that we deem not habitable for Earth life.
Mm-hmm. Do you think we're going to get into a position many, many years in the future where planetary exploration is really routine, where future humans are going to look back and think, what were you doing? You've gone and contaminated the entire solar system.
Absolutely. We look at human history, and that's been the case, when people from, Europe went over to the Americas and brought the common cold or other invasive species. It's bound to happen, I'm sure. And, we can do our best to try and prevent it. That's all we can do. But one of the problems with the private space industry, so for instance, SpaceX, as awesome as it is, they're not really beholden to any of the international treaties. It's more of a, trusting that you'll do the right thing. There's no actual law in space telling you that you're not allowed to, go to Mars without sterilizing your equipment. It's, it's a guideline that the space agencies really hold themselves to, but there's nothing to hold a private industry to those guidelines. So that is definitely going to be problematic. And where humans go, microbes go. So the best we can do is minimize the risk.
Mm-hmm. So to end on a more positive note, what would be the implications if we found life on Mars?
Well, they'd be massive, because it would be answering one of the most fundamental questions that humans have ever asked since the dawn of time. I think whether it would change anything day to day, probably not. It probably wouldn't change anything, in your daily routine, but just philosophically and how we perceive ourselves and our place in the universe, I suppose it would change everything. So nothing and everything at the same time, I suppose.
That's an excellent answer. So thank you so much for joining us this evening. This was really, really fascinating. And I hope that we'll be able to have you back when we're in person. But in the meantime, we're going to see if you ever want to come back, because we're going to subject you to our ritual speaker torture with John. So I'm going to hand over to John now.
Thank you very much, Rachel. So Jen, you're already got your video on and unmuted. So Prat, if I could ask you to do the same. Okay, so obviously we, here at Edinburgh Astronomy on tap, off tap, are always very grateful for our incredibly sort of intelligent and fascinating speakers. So we submit them to ritual humiliation right at the end, just so, we show our, appreciation, but also we put you through the mill, and then they never return for some reason. We've never worked out the connection, but this is what we do. So thank you both for being good sports. We usually are in a pub at this point, as Amy said. So we usually have a game, also a couple of games with our audience. So we've transitioned this to online. So I'm just going to share my screen with you both. Bear with me 1 second. Okay, so hopefully everybody can see this appearing on your screens. So this is our version of a game way back from my childhood called Mallet's Mallet. It is called Space Off. And essentially, 2 speakers enter, 1 speaker leaves. There are 3 rounds. One of you is the champion at the end of it, and the other one has a very meritorious 2nd place to take home. And completely happy with their night's work. So this is our 3rd anniversary edition of Space Off. So I'll explain the rules to you both. It's pretty straightforward. It's pretty simple. There is a bit of thinking going on. There is a back and forth between you both. So I hope you're okay with that. But it is pretty straightforward. Are you both okay? Are you ready to play?
Yeah.
Okay, great. So I will explain the rules. Basically, it's a word association game. I'm going to give you both a category, and then I'll go back and forth between you until one person's brain goes completely blank, or they repeat something, or they hesitate too long, and then the other person is declared the winner. I'll give you like a few seconds to have a look at the category so you can actually see what the category is going to be, have a few ideas in your head, and then I'll start the game and I'll jump back and forth between the 2 of you, if that's okay.
I have a feeling that I'm going to be really bad at this.
Same, Prats, don't worry.
Okay, so as I've explained, we have 2 players, both of you. We'll give you a category. You'll take it in turns to name things associated with that category. There'll be very specific categories, so it'll be easy to know which ones to name. And you can't hesitate, repeat, or wander off topic and start talking about the latest novel you read or anything else. So it's pretty straightforward. Do you guys understand the rules?
So just naming just things that come into our head.
Just naming stuff. Yeah. So it's basically just saying words that link to other words. Super easy. Okay, so perhaps as you were our first speaker tonight, I'm going to designate you to go first. Is that all right?
All right.
Okay, so what I'm going to do is I'm just going to click to our next screen. So the first round, I'm going to give you both the category, and then perhaps I'll go to you first, and then you have to say a word associated with that category. Then I'll jump back to Jen and then back to you. Is that okay?
Sounds good.
All right, so first category, pretty easy, astronomy related. Constellations. So I want you to think about constellations, names of constellations. So I'm going to jump back and forth between the 2 of you. I will note at this stage, if you make up a name, my training's not in astronomy, I'll probably miss it. So if it's reasonable enough, I'll probably just say, yeah, that sounds about right, and keep going. So if you have got a good imagination, you'll probably do okay. So Prat, I'm going to start with you. Constellations, go.
Ursa Major.
Back to you, Jen.
Ursa Minor.
We're going well.
Orion.
Jen.
Libra.
Prat.
Taurus.
We're going well.
Leo.
Keep going.
Scorpio.
Yeah.
Sagittarius.
Prat.
Aquarius.
Okay.
Pisces.
Aries.
We're still going well.
Pleiades.
Very good.
The North Star.
That's not a constellation.
I don't think we can allow that as a constellation, Prat, unfortunately. We did very well there. Normally we get to these sorts of things and it's an astronomy topic and we have astronomers and we get to about the 3rd thing and somebody panics and just kind of switches off their camera and runs away. But I'm afraid I'm gonna have to give that first round to Jen. Jen, congratulations, you are the winner of the first round. Okay, so Jen, I'm going to start with you the second round as you are currently in the lead and you're the second speaker. So our second topic, again, I'll give you just a few seconds to think about it. Our second topic is robots in movies or TV shows. So these could be characters, these could be a kind of robot that's in a certain TV show or a movie. I'll allow for both, but basically I want to know the names of robots in either movies or TV shows. Okay, so Jen, I'm going to start with you. Go.
Hal.
Prat.
Terminator.
Very good. Jen.
What did he say? What did he say?
Prat, say that one more time.
Terminator.
Yeah, that's a robot.
Marvin from Hitchhiker's Guide.
Yep.
Oh, darn it. Mac and cheese.
I'll accept it. I don't know what it is, but it sounds right. I trust you. Back to you, Jen.
Wally.
Very good.
Ewa.
Very good. Oh,
that was going to be my next one. Oh, I don't know.
I'm just about it. Well done, Prats. Prats, you take round 2. Very good. Well done. It's really hard because when you go back and think about it afterwards, loads of them appear in your head. You know, you think about like Futurama and like Bender.
Oh yeah, Star Wars.
Batteries Not Included, Star Wars, yeah, Star Trek. They just kind of keep coming out of your head, but it's really hard to think of in the moment. This is the perfect speaker scenario. 1-1 going into our final round. Okay, you both ready?
Yeah.
Great. So Prats, you're going to start again. Now I will say this might favor Jen just because of her talk. So
Fair enough.
third category. Things humans have left on the moon. So wherever humans go, they leave litter. This is a constant in humanity. We leave litter everywhere. We left about 220 tons of stuff on the moon. All this stuff has just been left there. It's terrible. It's like it's a Tesco parking, car park. It's awful. So I want to know some of those items that have been left on the moon. They can be anything that are the remains of humans on the moon. Okay? So I'll give you both a second to think about it. Got some ideas? Okay, so when we're ready, Prats, I'll start with you. Things humans have left on the moon. Go.
Debris.
Yep, I'll allow that.
The flag, American flag.
Yep. Oh, hold on. I've lost my slide. Bear with me 1 second. The American flag. Yep. Keep going, Prats.
The moon lander.
Yep. Moon lander. Yep.
Footprints.
Very good. Footprints. That's a good one. Yep.
What else? The probes.
Yeah, there's been lots of tools and probes left out there.
Mirrors.
Very good. Mirrors. Yeah, very, very good.
Yeah. Ooh.
Think of some non-traditional stuff that people might have taken up there.
Oh, I do remember that Neil Armstrong and the first batch of astronauts weren't that careful, were they?
No.
I just can't remember what they left. Ooh, let's guess. What should we say? Should we say some stuff from skin cells?
They're wearing suits. Hopefully they're wearing suits.
Tell you what, I can't verify it, so I'm going to allow it for the sake of tension. Jen, back to you.
Oh, I don't think that's true, but well.
Human waste.
Oh,
there are lots of bags of poop. There's about 6,000 bags of poop on the moon, just so everybody knows. So there you go. Back to you, Prats.
Oh, I'm really struggling. Did they say that they were installing solar panels?
I don't have that on my list. I don't know if I can verify they've left that.
All right. Well, then I lose.
Before I let you do that, Jen, did you ever follow up?
I had the lunar car that they drove around on.
Oh,
They've left multiple lunar buggies. In fact, and I think Jen will have to give that one to you because I can't verify. And also, I let skin cells go, which I'm not sure about. But they also.
I hope there's no skin cells, otherwise they would have a puncture in their suit. That would be bad.
There've also been a javelin, golf balls, cameras, bags of poop, as we talked about, some artwork, a small sculpture, human ashes. Someone got their ashes put on the moon, and a small family photo as well. So those are the things we left on the moon. Congratulations, Jen. You are our champion today, and thank you both
Thanks,
for playing. Congratulations, fantastic. All right, so I'm going to stop sharing my screen just now to thank both of you again for playing, and I'm going to hand back to our host, back to Rachael.
Thank you very much for that. That was fascinating. And somehow in the year that Astronomy on Tap has been online, we have managed to cover toilets deep underground, in Antarctica and in space. So that is the level at which we're working here. So thank you so much to everyone who joined us this evening. Thank you to our speakers, Prat and Jen, for joining us tonight. Thank you to Fred and Amy and John for doing the games, to all the other men that we have in the background on the team who were very gracious about me only introducing the women at the start. We do have men on the team as well, and they're great. Thank you very much for joining us this evening, and we hope to see you again next month. Until then, good night.